All right, so here is lesson number 2. We're still talking about continuity. All right, so you are hiking up the Sleeping Giant Mountain. The elevation begins at 184 feet above sea level, and the top of the mountain reaches 738 feet. I think I looked this up online just so I think it's accurate. If you reach the top of the mountain, are you ever exactly 500 feet above sea level? What do you think? Well, duh, right? Seems like silly, right? So we have this mountain, and we're starting at 184. At the top, it's 738. We have to, at some point, hit 500, right? We're not magic. We're not, teleporting. We're not in Star Trek. We're not, magically skipping over the 500, right? So we have to hit 500 at some point. All right, if a function is continuous and on an interval, its graph has no holes or gaps on the interval. If a function is continuous on its domain, it will be continuous at every number in its domain. Its graph may have holes or gaps at numbers that are not in the domain. So you need to pay attention to the way they're wording it. Sometimes we're talking about continuity in general, continuity at a point, continuity on the domain. So you need to see what exactly are they referencing. All right, theorem. Continuity of a composite function. If a function g is continuous at c and f is continuous at f of c, then the composite function is continuous at c. So if the two pieces are continuous, then you know you're good. Determine where each function is continuous. So this is why we went over domain and range, because really what this is asking is what's the domain of this function, right? So pause the video. What's going to be true for number 1? What's going to be true for number 2? All right, so number 1, x squared plus 4, that's all real numbers, right? It's continuous. You can plug anything in, nice smooth graph. Nothing weird is happening. And we're only focused on x values also. Number 2, that's that square root where we need the inside to be greater than 0. So x has to be greater than 1, or x has to be less than equal to. So. All right, so that's it. All right, so this is the intermediate value theorem. We also call this the IVT. This is one of the theorems you need to memorize. There's 3 or 4 that you actually need to know what they are and what they say. They are used a lot. If they have a name, typically those are the ones we need to know. So this says, let f be a function that, I spelled that wrong, I typed too fast, is continuous on a closed interval a to b, and f of a does not equal f of b. So the two y values are not equal. If n is any number between f of a and f of b, then there is at least one number c in the open interval for which f of c is 0. It equals n, sorry. All right, so I'm just going to draw a random graph. So the y values have to be different. So I'm going to go there. Okay. So this is A, this is B. And then they also have the y values, f of A, and then over here, f of B. So what this is saying, if there's some n value, right? Now the n is between f of A and f of B. So n is a y value. All right, it's a y. So I'm going to pick an n anywhere. So this is saying if there's an n, then that n, that has to have an x or a c that falls between a and b. There has to be a c somewhere. If there's an n that falls between the y values, then the x value that goes with it has to fall between a and b. So that's what the intermediate value theorem says. And that's basically what I was trying to get at in the do now. If you have a mountain that you're walking up, you hit that 500 is between the 180 something and the 700, like you have to hit it. There's no option. You can't skip over it, right? You can't skip over n if it's continuous. All right, so use the IVT to show that f of x equals x cubed plus x squared minus x minus 2 has a 0 between f of 1 and f of 2. All right, so first thing we always need to say, with the intermediate value theorem, we have to be continuous. So I'm going to start by saying f of x is continuous. And I'm going to say since it's a polynomial. It's a polynomial. Oh no, my pen fell off, turned off. Polynomial. Okay, so now we need our y values, right? F of 1 equals 1 plus 1 minus 2, which equals -1. F of 2 is 8 plus 4 minus 2, which equals 8. All right, so we have our y values, are -1 and 8. Does this function have to have a 0? Well, yeah. Again, if you think about it, this is a polynomial. So we know the point 1, -1 is on the graph. And we know the point 2, 8 is on the graph. To connect these, since this is continuous, we have to go through 0. There's got to be a point there. There's no way to just skip over y equals 0. It's impossible. So f of x is continuous since it is a polynomial. Since 0 is between -1 and -8, there must be a c value such that f of c equals 0. That's it. So we have to say make sure you say continuity. Make sure you talk about 0 being between the two y values. And then just say, okay, there has to be, did I such that? I said such that. Wow, Brianna. Such that. Okay. F of c equals 0. All right, same idea. Try this one on your own. All right, so I'm gonna start actually by finding my y values. So f of pi over 4 equals 2 times root 2 over 2 minus pi over 4 plus 1. So that's root 2 minus pi over 4 plus 1. And I'm just going to say that's greater than 0. Like, I know that's greater than 0. Because pi over 4, that's 3/4, right? So that's definitely a positive. And then f of 3 pi over 2. So that would be 2 times, what is that, -1? Sign, yep, -1 minus 3 pi over 2 plus 1. So that ends up being -1 minus 3 pi over 2, which is less than 0. So I have something positive, something negative. So now I'm going to write my statement. F of x is continuous. I always start with that. And you don't really have to say why, as long as you say it and you're like convinced yourself, because the AP people, I just want to know, like, I just want to know that you know. Like, you don't have to say why, as long as you're right. You don't have to be like, well, it's a polynomial and blah, 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 or it's a trig, a sine is continuous everywhere. You don't have to go into it. You just have to say it. F of x is continuous. F of pi over 4 is greater than 0, and f of 3 pi over 2 is less than 0. since 0 is between f of pi over 4 and f of 3 pi over 2, there must be a c such that f of c equals 0. Right. So I'm saying the y value is between my two other y values, so there must be an x where f of x is 0. Right. There is a, if you want to use it, you don't have to. That symbol means such that. It's just a common phrase used in math. All right, so now here is an example of an AP problem that you could see on the test. It's usually like a part of another problem. It's pretty common. It was on last year's exam, something like this. A car travels a straight track. The car's velocity and acceleration are continuous. Notice they say continuous. They have to say that. The table above indicates selected values of these functions at time t. For 0 to 60, must there be a time t when v of t equals -5? Justify your answer. So does the velocity have to hit -5? What do you think? Well, hopefully yes. So pause the video and write down what you think a good explanation would be. So I'm going to start with, again, continuity. Since v of t is continuous, I'm going to go with, it actually doesn't matter what you pick. You can pick a bunch of different ones. I'm going to do 35 and 50. Since v of 35 is -10 and v of 50 is 0, -5 is between these y values. So there must be a c between 35 and 50. You could say t equals 35 and t equals 50, such that v of c equals -5. That's my explanation. Again, it's not overly crazy. It's 2 sentences. It's not that serious, guys. All right, one more. This I typed out, but this is also a AP problem that have been on the open-ended sections of the AP test. Let f be continuous functions such that f of 2 is 5 and f of 5 is 2. Let h equal f of x minus x. Is there a value r for 2 is less than r is less than 5 such that h of r equals 0? So they never say IVT, they just describe it. So they're giving me this interval, right? So don't ignore that. So we're going to start by finding it. So they're asking about h. Notice they give you info about f, but they're asking about h. So I'm going to find h of 2, because that's an interval. Now, when I plug in h of 2, that's f of 2 minus 2. Well, f of 2 is 5. 5 minus 2 is 3. Now I'm going to find h of 5. H of 5 is f of 5 minus 5. F of 5 is 2, and we get -3. So that's good, right? We have a positive and a negative. So now justify your answer. Since f is continuous, h is continuous. We have to say that, right? Since f is continuous, h must be continuous. H of 2 is 3, and h of 5 is -3. since 0 is between these numbers, there must be an R and R between 2, I could just write the interval, such that h of r equals 0. And then sometimes I'll just say, I'll throw in by the IVT. You don't have to actually say the IVT, or sometimes I'll throw it in by the beginning. By the IVT, f is continuous, and we have the positive, we have the negative, the stuff has to be between it. That's it. All right, and here is your homework for 88 and 89, only do part A. All right, email me if you have questions.